Everybody getting hopped in really quickly. Chris and I had a quick conversation before the stream. They did a really good job kind of covering NVIDIA, or at least the 10-15 minutes of the call that I listened to with respect to finance junkies. They had Tevis and folks on. So we're not going to go too much in detail about it per se. But what I will say is that it was very impressive how it kind of just immediately kicked back up. And I was looking at the earnings report myself, and with it, I was just thoroughly impressed. And I think this just goes back to, you're going to see this age of opportunity where you get Hot Chris is back. You get an opportunity where there's going to be the phonies of the world with AI, and there's going to be the folks that actually utilize it to their advantage. And I think everyone's going to be talking about it, right? Just like the internet. Everyone was talking about the internet. Everyone was talking about smartphones. Everyone was talking about cloud. Now everyone's talking about AI, and who's actually going to end up using it at the end of the day is what's going to be truly important kind of going forward. So, Chris, I was just letting him know we're probably not going to dive too much into NVIDIA or anything like that, but we did have some thoughts, or you had some thoughts last week about some companies that are already implementing AI and how we could talk about that. And I think that feeds into a little bit about why there's so much demand for these NVIDIA chips, why there's so much demand for the Snowflakes of the world, why there's so much demand for the Palantirs of the world. So enough of my little monologue. What's going on? How are you?
I'm good, man. The numbers today, they're speaking a story. And I think the story is important to understand. And the story is there is a technological revolution that's real, that's happening. And the demand for the principal player in providing that future tech is benefiting significantly right now. The only thing that I would say around it is that, you know, this is this is very similar to like any other technological revolution. Primarily, what I would speak about is like the internet. When the internet first came out, the possibilities were just endless, and then cloud computing came out, and the possibilities were endless. And we're nowhere near at the end of the game when it comes to cloud computing. And it's the same thing with AI, where I think this is a lot of this is just the beginning. The question is, from an investment standpoint, which part of that business cycle do you want to be part of? Do you want to be part of the hardware provider like Nvidia? Do you want to be the software provider? Do you want to be the end user of an AI potato chips?
We're talking about
No,
I'm sorry.
So
I was waiting for that all day. I was just like, I gotta scam somebody with this. Anyway, I'm sorry. It fell flat.
Yeah. So it's interesting to see how AI is going to improve our lives. And I think there are subtle things that are happening in the background with AI that people don't necessarily see because it's not in your face, right? With so many new technologies, when they first come out, they're like in your face, but they are in your face. You just don't recognize it. And I'm going to give you guys an example of a company that's actually utilizing some AI and machine learning to actually do some really cool and interesting things. But it's also something that's scaring a lot of people because it's supposed to like take people's jobs and whatnot. So let me just show you what I was talking to you about. Have you ever heard of Presto by any chance?
That name sounds so familiar. It's not ringing a bell though.
Okay, well, let me just show you guys really quickly what I'm talking about. So imagine right now you go through the drive-through, right? 99.9% of the time, there's usually a person at the other end. You give them your order, they fulfill your order, you come to the window, they give you your order, right? Now the thing is, right now we have a national worker shortage, and among that, the cost of right now hiring someone for a specific role like that is really hard. So how do you use technology to kind of bridge that gap, right? And the way that you do it, of course, is something like this. And let me just show you real quick. Share my screen.
Sorry, I'm looking for stuff in the background as well. Apologies.
Yeah. No, that's okay. 1 second. Share content. Okay, there we go.
What can I make fresh for you today?
AI is here in the Valley, and it's looking to take your order.
What else?
The new system is reliable. So it's there 24/7 and it really helps.
In partnership with Presto Automation, Carl's Jr. is bringing out artificial intelligence to take orders at drive-thrus, with one of the first locations in the country being in Buckeye. It can adapt to whatever you're saying and even offer other items on the menu.
Would you like to try our jalapeno poppers today?
I was a little taken back at first, and a very pleasant voice.
Store manager Augustine Medina says this AI isn't taking away jobs, but instead lets his staff focus on other tasks like preparing the food.
We're not cutting hours or cutting another person from the schedule. It's just someone else to help there.
We wanted to put this AI to the test, so we hit up the drive-thru.
Hi, what can I make fresh for you today?
Yeah, can I get just the famous star, just the burger?
Sure.
That's the simple order. Now let's throw it a curveball.
Can I get another famous star, no buns, make it a lettuce wrap? Hold the pickles, hold the onions. Can you hold the meat? Can you repeat the order back to me?
I have one famous star with cheese and one famous star with cheese with lettuce wrap.
And that's it?
1462, please pull forward.
Thank you.
My pleasure.
All right, let's see what we got. All right, the burger on my left, this one has no changes to it. Simple enough, but the one on the right, this is my custom order. As you can see, I got rid of the buns in place of lettuce. It has no pickles, no onions, just cheese, just the way I ordered it. Now, typically I wouldn't get something like this, but hey, it got the job done.
The process is a little slower than talking to a real person, and it's also not perfect.
We're always wearing our headsets, so we are always ready to jump, to intervene.
Oh my gosh.
Am I on mute or are you on mute? Me.
I'm not on mute. I'm on mute.
All right, there you go. Got me scared.
I think this is the thing that like a lot of people don't necessarily see that's so up in front of them, but this is the kind of stuff that's happening. You know, I'm also seeing some technology around optical reading for like fruits and stuff, where basically when you do your self checkout at like Walmart or Kroger or wherever, you know, you put the fruit down, it automatically detects what it is, where like you don't have to like fidget around on the screen to figure out, you know. Have you done the self checkout at the stores?
No, but I was thinking when you said the Amazon carts that I was thinking about with respect to like Whole Foods, that was kind of what my thought process was. Sorry.
Yeah,
that's what I was
no, it's just I was just saying, like, this is the kind of stuff that's like being integrated into our daily lives, and we're not even technically noticing it. You know, there's like some other things that I'll show you guys as we go a little bit further, but the one key thing that I want to just highlight is there isn't an AI supercomputer sitting at Hardee's. Like, that's not how it works. Usually what happens is there's a data center that's inferencing the stuff all the way somewhere in the middle of Wichita, or, you know, someplace where they have a giant data center. It's being actively cooled. And that's where all the GPUs and everything are. The CPUs are, the servers are, where you're training all these models, so that this way, when that person speaks to that speaker box, the model is already built in and understands what you're trying to say and get at, right? Which is not what you had 5 years ago. So right now, you're basically taking audio, translating it into text, using the text, run it against an AI model to figure out what the person is actually asking for, and then giving a prompt response, creating the order set, and putting it together. And it's a freaking cool thing, because now that's one less person that you have to worry about when you're running a restaurant, on the ordering side. Now, that's not to say that the human can't take over, because humans can take over at any time.
For sure.
But what it is when things are super busy, you don't want just one person at the window at the drive-through. You kind of want people to be circulating around, and you want to give people, you know, ample opportunity to not have to deal with just the customer end of it. So it's just a very cool thing to see, you know.
So this makes you think, I mean, Chris, you understand the ontology of things, right? That semantic layer, that kind of right. So, and I don't mean to specifically go into Palantir, but I just mean in general, right? When you're looking through and trying to sort all this data, whether it's from voice, whether it's from just, and having that AI have to interpret all that and kind of understand what you're referring to. Call it a machine or model library, call it whatever you want. I mean, do you start to understand why there's so much push around data analytics and data categorization and the snowflakes of the world, and really start to hone in on some of these things? Because if you don't have that appropriately set up, it might think that the protein is the lettuce or the tomato, and it's like, in reality, you're talking about the protein, you might be talking about the burger itself, or the, whether it's beef burger, chicken burger, chicken patty, fried, grilled, that's all kind of important when you're kind of going through, okay, add this, subtract that. It's like, well, some things you can't add when it's a burger, right? Or some things you can't subtract when it's a burger, right? Like, obviously, if you're ordering a cheeseburger and you say subtract the patty, like that doesn't really help out anymore. It's not a burger, it's something else, right? You're asking for a salad at that point. So all these sorts of things are very important. I feel like that's where I'm kind of curious as to where everybody's guide rails are, right? I feel like for a restaurant, it doesn't take much to set up something like that, because there might be 80 to 100 different items that you might have to understand where to add, subtract, which one, what relationship plays with the other, the limitations of what the AI can kind of handle. But I'm curious what other things can this be applied to, and I think the one thing that I also was very intrigued about specifically was the voice, right? And I know that we've had that sort of opportunity to use Alexa and Google Home and stuff like that to truly utilize that capability and kind of get into that space of AI. But I'm curious where else we can really start to see that implemented. And I mentioned this the other night, and this could have huge implications in hospital operating rooms of this.
So
I'm
I'm glad you brought that up, because there's actually one application I'll show you guys. It's not. I mean, I worked in an adjacent. I don't know how much I can discuss about it, so I'm not going to discuss too much of it. But I'm just going to take one step back in that what you saw with this whole ordering via AI and stuff. The thing is, the winners are what we're looking for, is in terms of like, who is going to be the ultimate beneficiary? Is it going to be the NVIDIAs of the world? Is it going to be the Microsofts of the world? Is it going to be the Googles of the world? And I'm confident in picking, believe it or not, Google as a main beneficiary. And I'll show you exactly why. Because I mean, even let me just show you real quick. Here you go. Can you see my screen real quick?
Yeah.
Okay.
Wendy's is partnering with Google Cloud to bring AI to its drive-thrus. Now, this is called Wendy's Fresh AI. The pilot kicks off in June in Columbus, Ohio area at a company-operated restaurant. Brooke DePalma is here with those details. Brooke, it sounds exciting.
Good afternoon. It certainly does sound exciting. Pretty interesting here. I'm eager to see how exactly it works. But as you noted, this is one of the first partnerships that have come out of this collaboration between Google Cloud and Wendy's. That partnership began in 2021. This is called Wendy's Fresh AI. The first pilot of Wendy's Fresh AI is set to launch in June in Columbus, Ohio, near its headquarters in Dublin, Ohio. Now, in addition to that, the company wants you to know that the AI technology has the ability to understand made-to-order requests, which they say includes billions of different combinations. For example, if a customer asks for a large milkshake, this technology will know that they're asking for a Frosty. In addition to that, they said that it'll be as natural as interacting with employees, eager to see if customers think so as well. And in this pilot, customers can expect a female voice. Now, what you also need to know is that Wendy's expects here to improve speed, accuracy, and consistency with this automated technology. And based on this pilot, Wendy's is looking for a few key things. In addition to that drive-through speed, the customer is also taking a closer look at order averages. They hope to see a boost in sales with upselling opportunities that the AI technology will offer, like larger sizes, asking customers customers perhaps if they want a Frosty with their orders in addition to daily specials. And this comes as drive-through remains a key opportunity for Wendy's. About 75 to 80% of Wendy's customers prefer drive-through. Now, Shauna, that's a big jump compared to roughly 2/3 before the COVID-19 pandemic. And Wendy's hoping to be not only a game changer here, but a leader in AI technology in the drive-through.
It certainly makes sense. It certainly seems like that with the recent moves there. When it comes to AI, we talk about how so many companies are talking about it on their earnings releases. It sounds like Wendy's isn't the only food company, not the only fast food chain that's incorporating AI. Who are some of the others?
Right, certainly not alone in that. In fact, this is probably the top, if not the topic of this earnings season. I mean, we heard McDonald's mention it in their earnings call, but in addition to that, they also teamed up with IBM back in 2021 to further accelerate and to development and deployment of their automated voice ordering technology. We've heard some customer feedback about the accuracy of it. A bit of a rough start there. Wingstop in March partnered with AI voice startup Converse Now. They're running a pilot where they're using voice AI-powered virtual assistants to take customers' phone orders at select locations. We're also seeing Yum brands using recommended ordering to understand how much food is needed at restaurants, and Chipotle using AI for kitchen management to streamline operations. They also introduced Chippy, the robot, and what they call an AI kitchen assistant to make chips. Chipotle CFO also weighed on the opportunity, saying that it is taking a well-thought-out approach. Take a listen.
There's a lot of possibilities. There's also a lot of pitfalls as well. So we want to be very careful, very thoughtful. But certainly, if there's ways we can make the job that our crews do, the jobs that our support staff do to support our restaurants, easier, better, and if the end result is we can run better restaurants and serve the customers in a better way, we're certainly going to look at any technology.
And of course, this earnings season's not over yet. There's more food companies set to report later on this week, including Wendy's before the bell on Wednesday. We also have Cheesecake Factory after the bell on Wednesday, in addition to Krispy Kreme Thursday.
Yeah, but you see that now it's starting to become one of those things that's being entrenched into already existing infrastructure, right? And this is where the true alpha is, because the companies that can provide that AI infrastructure, they're just going to have this long tail of sustained revenue for like ever, because essentially they own the infrastructure, they own the pipes that make AI happen, so that's why.
My question is, Chris, sorry, I know I cut you off mid-sentence, so it's like,
yeah, go for it.
Why would it be appropriate for the use of, say, like IBM's Watson quantum computer versus, say, like an AI chip from NVIDIA? Like, what would drive somebody to use the chips from, say, NVIDIA versus a quantum computer, right? And I know that one's a GPU, one's a CPU, right? But I'm just kind of curious, is like what both are just trying to solve calculations. So I'm just trying to understand in the back of my mind, what's really going to power the future? Have we just like surpassed with these GPUs the need for even quantum computing? Is quantum computing still necessary? Is it like, I'm just trying to understand and differentiate. Like, I guess I'm just not that tech savvy enough to truly understand the use cases for either. And I'm agreeing with you 100% of, you said this earlier on Finance Junkies, and I agreed with that 100%. It's like looking at something like an NVIDIA is probably out of the market at this point. It's up however many hundreds of percent, thousands of percent even, up over 100x, 200x, or whatever in the past 20 years. There's probably other companies out there that will benefit from it, that will kind of implement small tweaks that will be huge game changer and company makers for them. And how I guess my thought process is, if you dived into the due diligence of what we're actually talking about here, the specifics of the industry, what are we looking for? Is quantum computing still there? Is it only, say, AI chips from GPUs? Like, what? I'm just not smart enough, and I'm just trying to pick your brain.
So what you're asking right now is a debate that's a little bit different, where one is more machine learning and this one is actual AI. So it's a little bit different. And even how the technology is implemented is something that we all have to kind of learn together. I know I'm going to just show one more video. It's more training so that we understand the core concept, because even me, I'm trying to, learn myself. So let me just show you this video. So the debate that we're actually having is something called it's between inferencing versus learning, right? So let's take a look and just it'll help explain things. It's funny that this is actually from ARMS.
Yeah, I was gonna say, when's IPO?
Hi, and welcome to ARM's What Is program. In each episode, we dive into a tech topic to give you insight and perspective into some of the hottest design trends today. I'm Brian Fuller, editor-in-chief at ARM, and today we're going to explore AI inference, or to spell it out, artificial intelligence inference. AI is obviously a hot topic and a growing application space, but it can seem like a complex technology landscape. Today, to help us understand one aspect of that landscape, AI inference, are two of my favorite people in the space, Dennis Laudick and Steve Roddy. Dennis is the head of AI machine learning marketing at ARM, and Steve is head of products for AI and ML. And here's something a lot of people don't know about these guys. Dennis got an engineering degree, but he minored in philosophy. And that comes in handy in the AI world. Now, Steve dabbles in a lot of different sports, and for his efforts, he's broken 13 bones. Let's dive right in. I'm going to start with Steve. You're looking good today, my friend. What is AI inference and how does it work?
So in the world of AI, or more specifically machine learning, there are two phases, if you will. There's the training process. That's the process of actually developing the particular piece of AI. And then when you deploy it and use it in a real life situation on new data, that's called inference.
So just to start off, right now, H100s and everything else from NVIDIA, they're used for learning, for machine learning, right? What he's going into is something different, which is the actual use cases. And this is where there actually could be some more future opportunities coming for us. But right now, just remember, when you're going to do training, your model training, all of those things are thanks to NVIDIA's magic GPU chips.
So train based on recorded, stored and labeled images or sound or data, and then deploy in a new situation and use the AI to help augment human decision.
So at the technology level, how is inference implemented? Is this done on CPUs or specialty processors or something else?
Yeah, that's an interesting one. I think the industry, again, is a little bit confused about this. Certainly they have been. I think there's some clarity coming out of it. Machine learning can be run on any type of processor. It just depends on what you're trying to do. So, machine learning, it's just computing. It's the same thing we've been doing for decades now. The difference with machine learning, or what is often called artificial intelligence today, is there's a massive upshoot in the particular types of computing they want to do, like many orders of magnitude. And so if you want to do that at really complex versions or high performance or really high efficiency, that's when you can get benefits out of using a computing architecture that's more tailored to those type of workloads.
GPUs.
Which is what you get with ARM's CPUs, or GPUs, and our NPUs. They're all kind of different variants depending on what you're trying to achieve with your machine learning.
Got it. And Steve, is AI inference done mostly in the cloud, or is it starting to move out to the edge and endpoints?
Good question. The easiest way to think of it is the best place to run your model, to do your inference, is where your data is located. So
when these guys say edge computing, right, what they're meaning is literally at the point at which the interaction is occurring, right? Because you don't want a situation where, yes, the model can be trained somewhere at a data center, but then imagine every time you have an application running, it has to reconnect to that data center far off. The amount of time it takes to get that data come back, the latency is, even with modern technology, is kind of slow. You kind of want that instant reaction, right? So if I say to you, Matt, my name is Chris, right now you're not you're not using the cloud to figure out that my name is Chris. You're literally just listening, and your brain is processing it, and you're able to effectively respond because the amount of distance between your ears to your brain is like nothing, right? So that's the key that inferencing does, so that all these models are trained, but then they're inferenced on the edge, so at the site, at the local level, you know. So that's what they mean by the edge.
So certain problems, you've got all the data.
And this is where, God, I'm gonna get flamed for saying this. This is why I'm actually excited for Palantir Apollo, believe it or not, because this is what they use to deploy this stuff all over the place. You know, so when Apollo is on the edge, that's the thing that really is the alpha for Palantir. But whatever, I'm not gonna go too far into it. Otherwise, the Palantir people are they're gonna start writing the comments like, Chris is flipped. He's winning us again. And it's like, no, Chris is not back yet.
Darth Chris is back.
No, Darth Chris is not back. Stop it. Stop it.
The data stored in the cloud. And that could be something like, you know, some financial analysts on Wall Street, you know, looking at stock trading patterns of the last 20 years and trying to predict where, you know, the stock goes tomorrow morning. Well, obviously all the data is stored on the servers, or all the ways that machine learning is used to make recommendations when you log into your favorite shopping site. Your data is naturally in the cloud. That's where you want to run it. There's plenty of other applications where the data is being sensed somewhere out in the real world, out on the edge or the endpoint, as they say. So, you know, if you have a smart doorbell, a smart door lock that you know, recognizes your face as you walk up to it and wants to unlock your door, you want to do it there. You do it there because it's more reliable there. You don't have to rely on internet connection. You don't have to beam the data back to a data center somewhere. You know, worry about your privacy, worry about the latency of it coming back and forth. So the world has evolved to apply the inference, you know, at the point in time where the data is being created or stored. And it makes it much more energy efficient too, rather than trying to, you know, beam streams of video back and forth from cameras to cloud, et cetera. So that's the setup.
So obviously the relentless march of technology is enabling us to deploy this technology farther and farther out. Dennis, how do you see, you know, given that scale and advancement that we've seen in the last few years, how do you see AI inferencing evolving in the next 3 to 4 years?
Yeah, I mean, I'm a little bit biased because I work in the AI industry, but I really do believe that over the last 5 years or so, I think Steve and I have seen an explosion of applications out on the devices, and that's obviously what we spend a lot of our time focused on, is enabling that. But we're nowhere near seeing the end of where this technology can go. So recently we've seen, you know, the early phases were about performance and accuracy. More recently, what we see in machine learning is a focus on efficiency and making things smaller and being able to put them on devices around you. Even tiny sensors get better with AI. So we see this stuff going everywhere. It's really exploding across the ARM device world.
Well, thanks, gentlemen.
Okay, so
I have a question for you. Actually, I'll let you explain that a little bit more, because I probably, a lot of it went over my head, but then I have some specifics that I wanted to ask.
Okay, go for it. What's the question?
Okay, well, I didn't know if you wanted to talk a little and like finish that,
okay,
but...
so basically, when it comes to these GPUs, they're really good at doing the model training. And the thing is, you constantly keep having to do model training. It's not like you train one thing and that's it. You never have to train it ever again. You know, no, you keep training. That's the thing. You gotta keep training. You gotta keep training. You create new models. The model degradation happens. You retrain it. You make it more accurate. So as you make it more accurate, it's really good. And so you can use that model and then you would deploy it to the actual applications out there. So that's where the value proposition of NVIDIA is, which is the training. The training is done by NVIDIA. You take that and you deploy it to the edge. And usually the edge deployment is done by usually a circuit board or a chip that has something like an ARM chip in it, right? That's why NVIDIA tried to buy ARM out, because then they would own both spaces. They would own the modeling and they would own the inferencing spaces. So that's one of the highlights where ARM could one day end up becoming a really major player. The problem is that the monetization on how ARM architecture is monetized is going to be the real key to all of what's going to happen in the future. The reason why I brought this up is because everyone, when they look at AI applications, they automatically think, oh, NVIDIA is the one that's doing it. So NVIDIA is the one that's going to get most of the alpha. And the truth is, to a degree, they will, because they're the hardware providers for now to the cloud providers who can do all that, who do all the modeling and the machine learning part of it. And then it goes to the other. But in my opinion, eventually they'll get to the point where the training will be done by processors that will be developed by internally by their biggest clients right now. So like the Googles of the world, the Microsofts of the world, the IBMs of the world. And that's the key that I want to kind of highlight a little bit, because we as investors, we want to look at what is going to generate the most amount of return for us. So which part of the chain do you want to invest in? Do you want to invest in the hardware provider, who's right now the number one name in the town, because today is what you're looking at? Do you want to invest in the cloud providers who already have a niche business that they're going to be able to kind of just keep expanding out further and further? Do you want to invest in the application creators like Presto AI, who created a talking bot that lets people do the ordering, right? Which one do you want to be a part of from an investor standpoint? And that's the key that I think over the next 5 years, we're going to have to slowly figure out, because we want to generate the most alpha, and we want to see who are the people that are going to benefit the most. In my opinion, right now, based on what I'm seeing from like taking a step back, it's the best investment in terms of undervaluation, in my opinion, is Google. Google AI is absolutely killing it out there. So is Microsoft, and so is Amazon. Don't get me wrong, but I think Google is the one in terms of valuation that hasn't got the valuation bump that Microsoft has. Like Microsoft's valuation is, I think, almost 60% higher than Google's is right now. So that's the key that I'm trying to understand and see from an investor standpoint. Who do I think has a pretty moat-like business, which is Google, using their Google search? And then how is that going to end up playing into developing their own chip stack? And then that chip stack ends up becoming a part of their AI model training. And then eventually, maybe they don't need NVIDIA as much. They're still using NVIDIA.
And I want to take that step, like you hit it, and you said it on Finance Junkies, and I was like, really good point, because look at what Apple did with the M1 chip, right? And how they got rid of Qualcomm, and so let's take another step back and talk specifically about NVIDIA, not going deep into it, but the net margin that you guys saw jumped, I think, from like the 40s to the 70% range. And so what does that mean? It means that, they used to make an 80% return off of every chip they sold last year. Now they're making like a 200% return on every chip that they're selling, basically. And that's what Chris is kind of talking about. It's like, and let me just take another step back, right? If you think about it, why do you think Walmart sells at a 1% to 2% margin? It's because they want to eliminate all the other retailers. Think about how competitive the retailer space is. And so in order to sell as much volume as you can, you have to shrink your margin. So think about then if Walmart were to have to go pay for somebody to kind of create a different thing, and basically it eats away at their margin. It's the same exact thing with NVIDIA, right? If you have so much margin that you're making off of these chips, you're going to start cutting out the middleman. And that's when I also wanted to kind of follow up on, you touched on it already with Google and their TPUs, and which I think is tensor processing units, then the neural processing units that I'm probably getting it wrong, the NPUs that they mentioned a little bit in that ARM video. And I want to know specifically about, like, what's the true difference between each of them, kind of like what I asked the quantum computing question earlier. It's like, what's the true niche, and what are we truly looking for? Because the GPU, it seems like it's going to be doing something that's very repetitive at a very fast rate, kind of like on a very consistent basis, versus when you're looking at, say, like a quantum computing, it's looking at solving very long code. So it's like one long continuous string worth of something where it's trying to compute it as fast as possible, versus like the repetitive piece that you're kind of talking about with machine learning and having to reset and kind of retrain and all these things. All these things are looking to do something very specific. And I'm wondering, I don't know. So I'm hoping that you do. But if you don't, I mean, it's something for me to kind of take away from this conversation and be like, I need to figure out more as to where we're heading and where, like you said, that alpha might be generated. But anyway, back to you because you have an article up. You're on mute, my guy.
So you can see here in this article, like NVIDIA is making an absolute killing on their H100 GPUs. Like, look at this. It costs them $3,200 an estimated per each H100 chip. They're getting $25,000 to $30,000 for each of these chips. Look at the markup on that, dude. 1,000% profit per chip. That's nuts. That's fucking nuts. So when you think about it, it's almost like in their best interest, these cloud providers that actually are buying these things from NVIDIA to cut the middleman out because it's so goddamn expensive. And so that's why you're seeing a lot of them developing their own AI chips. Hold on one second. Let me just, damn it. I had a video for it that I actually had. If you give me a minute, I can look for it and then we can watch
for sure.
it. 1 second.
But that goes back to what Chris was kind of saying, right? He worded it very perfectly on Finance Chunk because it's like, it only costs you $2,500, $3,000 to make these chips, and you have to spend $40,000 to get it. 1, and then 2, you have to wait on the supply chain to get it, and then 3, are they being purposely held back? I think is another piece of how much are they actually selling versus how much could they sell. And not only that, but you're also facing competition across a multitude of different people. It's like, could you have the opportunity to go directly to ARM or to any of these other contractors and build these chips yourself? It might take, let's just say, a couple $1 billion to kind of come up with. But if you're able to shave off literally, let's just say $45,000 or $40,000 worth per chip or per GPU that you're buying, it probably can add up pretty quickly, especially if you're going to continue to use the technology. And Ohm's law kind of plays into or Moore's law kind of plays into a fact as well, where you're probably having to replace out software, hardware on a lot of these data centers in a very rapid succession every 3-4 years. Anyway, just some food for thought.
So what we're going to watch right now is just a quick video on where everyone else is in regards to the AI chips. Like right now, by all means, NVIDIA is this leader. Okay, there's no even doubt. Today, NVIDIA is the goddamn boss of AI. But that doesn't mean everyone's going to let that happen forever. So let's watch it together.
NVIDIA reaching a $1 trillion market cap, it almost seems like GPUs are the only hardware for the future of machine learning. But hidden from the spotlight, all big tech companies, including Google, Microsoft, Amazon, Meta and Tesla, are working on specialized custom AI chips to power their own neural networks. Let's take a look at what big tech has been working on behind the scenes, because there will be a large gap between the winners and the losers of the AI hardware race. Custom AI chips are a new generation of hardware. When machine learning started to gain traction, researchers quickly realized graphics cards are much better suited for AI workloads than processors, because GPUs have a lot more cores than CPUs do, and AI calculations don't need the large instruction sets a CPU offers. That's where custom AI hardware comes in. They are silicon chips specifically designed to accelerate AI training and inference workloads. They pretty much only consist of lots of tiny cores and are limited to instruction sets relevant to machine learning. At the same time, a lot of research and design is needed to catch up with decades of GPU development. It's not easy to create new hardware from scratch. There are two reasons why every big tech company is currently developing their own custom AI chips. One is more performance and especially higher efficiency, as running large neural networks is very cost intensive. But the second reason is equally as important. No one wants to spend hundreds of millions of dollars on NVIDIA hardware, when you could spend the money on your own chips. The best example is Facebook, or rather Meta. Analyzing their quarterly earnings shows an obvious trend. Starting Q1 2022, we see a sharp rise in research and design spending, followed by a huge increase in capital expenditure from around $4.5 billion to almost $10 billion a quarter. If I had to guess, the increase in R&D is Meta ramping up their AI and machine learning efforts, and the increase in CapEx spending is them buying a lot of Nvidia GPUs. But we don't have to guess. Meta literally said so in their 2022 financial call, and I quote, "The current surge in CapEx is really due to the building out of AI infrastructure, which we really began last year and are continuing into this year." And since Meta is presenting new data centers on their company blogs, we can see what they bought. Thousands and thousands of Nvidia GPUs to power their AI data centers. Meta is actually one of the top 3 players in the AI market right now, only behind Google and Microsoft with OpenAI. But what is Meta using AI for? Are they planning a ChatGPT competitor? Meta is using AI for what they do best, trying to get as much advertising money out of Facebook and Instagram users. Meta's entire recommendation system is switching to custom AI, so-called deep learning recommendation models. Just 2 months ago, Mark Zuckerberg said the following: "Since we launched Reels, AI recommendations have driven more than a 24% increase in time spent on Instagram. Our AI work is also improving monetization. Reels monetization efficiency is up over 30% on Instagram and over 40% on Facebook quarter over quarter." Meta knows the huge impact a specifically trained neural network has for recommending the perfect content to its users, keeping them on the platform and thus making more money. If you caught yourself scrolling on Instagram or Facebook for longer than usual, AI is already affecting you personally. At the same time, Meta also knows how expensive Nvidia GPUs are. They literally spend hundreds of millions of dollars on them. That's where custom AI chips come into play. Just a few weeks ago, Meta unveiled their first custom AI chip called MTIA version 1. MTIA is short for Meta Training and Inference Accelerator, a pretty straightforward name. Meta's new chip is supposed to accelerate AI training and inference, although version 1 is more geared towards the inference part, which means running a machine learning model that has already been trained. MTIA V1 has a 373 squared millimeter large die and is produced by TSMC in a 7nm process node. The chip runs at relatively low 800 MHz, but at the same time only has a 25W TDP. Performance-wise, MTIA V1 achieves a little over lines on Nvidia GPUs. Google, on the other hand, has a lot of experience with custom AI chips.
I'm gonna like just skip in between each one because otherwise we'll be here for another 8-10 minutes. I'll put this video in the chat so this way people can watch it later. But this is very interesting, so let's keep going.
The so-called tensor processing units, or TPUs for short, are already on version 4. Back in 2015, long before the Transformer model, Google released their first TPU. It was a single chip with 8GB of slow DDR3 memory, only capable of inference. In 2017, the much larger TPU V2 was released. Now on a much improved 16nm node, it had 3 times the amount of transistors, a larger 16GB HBM memory, and supported both AI inference and training. The new bfloat 16 format was especially impactful and has since become one of the most commonly used formats in machine learning, as it combines large numbers with high throughput and can be easily converted from FP32. TPU V2 also included network links, allowing Google to combine up to 256 chips into a single AI supercluster called TPU pods. In 2018, Google released TPU V3, basically a V2 on steroids. The chip grew to almost 700 square millimeters on the same 16nm process node, was clocked much higher and used twice as much memory. The TDP exploded to 450 watts, which was offset by water cooling, and improved networking increased the TPU pod size to 1024 chips, allowing the creation of AI supercomputers. For its 4th generation, Google's not only switched to a 7nm process node, but also increased their lineup with a classic TPU V4 for training and inference, but also a TPU V4i specifically designed for inference only. This version is using its own chip. At almost half the die size, it's cheaper to produce, while delivering similar efficiency. This move was to be expected because while training large language models takes a lot of computing power, the much more difficult part Google and all other big tech companies are facing is how to run inference for billions of customers. If AI will become a part of search in the future, inference cost has to decrease by orders of magnitude, only possible with customized AI silicon. But Google isn't only using their AI chips internally. You can rent them as part of Google's cloud offerings. If you need to train a large language model or run inference for your already trained neural network, Google Cloud has you covered, and you can rent everything from individual cards to whole TPU superpods. And while Google also offers Nvidia-based systems, I think the direction is clear. Google is closing in on a decade of experience designing and using custom AI hardware. they certainly don't envision a future based on NVIDIA GPUs. Before
So I think this is the key thing to look at for Google going forward, in that if they can do their hardware themselves, rent it out. And by the way, the traction that Google AI is getting, Matt, from the research that I've done, is fucking phenomenal. So I think a lot of people are looking at NVIDIA and, going ooh and ah. I'm looking at Google and going ooh and ah, because a lot of this stuff is going to be making its way through the system, and eventually Google is going to be in one of the best positions to monetize this via their Google Cloud AI.
Well, my thought process is like I'm just doing a little bit of research behind the back scene, and I'm curious what your thoughts are, and then we can get back to the video because it looks like there's still a lot left.
Yeah.
The thing that I'm starting to look at and recognize is like our GPUs, specifically the name graphics processing unit. Are we getting to the end of a, say, GPU specific era, and then going towards what Google's talking about, which is TPUs and NPUs, which is neural processing units, where you're actually getting more specific about what you're going for? Keep in mind, like I'm not saying that GPUs are garbage, but the same reason why we don't use CPUs for graphics, right? And we came out with graphics processing units. It's like now we're getting to a place where we're maybe expanding beyond what a normal graphics processing unit can provide. And so that's why Google and many of these other people are starting to recognize and move into this more specific type of processing unit, to the point where, probably like 8-10 years ago, nobody really even knew what the hell a GPU was. And it came out with mining cryptocurrencies and huge video games and all these things. It's like, okay, cool. Are we getting to the place now where we're out spanning that sort of cycle, and you need to create TPUs in order to be competitive and cost effective and faster and more efficient? And so that's where my mind is heading now. And I'm curious if that's going to come up later.
Yeah, it's all,
or if that's what you thought.
Yeah, no. Well, I close the video only because all it does is say the same thing, but it just shows what each company is doing. I'll send you the video after this, but basically everyone is trying to figure out how to maximize their use cases, whether that be selling to third parties, the ability to do their own AI modeling and everything else, like Google or like Meta. Meta is just utilizing NVIDIA chips to do what its core business is, which is advertising and engagement farming, right? That's their Meta's model, right? The thing is, Meta's like, I don't want to pay NVIDIA for the rest of my life to keep doing this. I'm losing so much margin by being beholden to NVIDIA. Same thing with a lot of these other companies like Microsoft, Google. Right now, they're all fair with their friends because they need NVIDIA. So none of them are going to come out there and say, oh my God, we're trying to replace you. All they're going to do is, yeah, NVIDIA, you're the best. You're the best. Give me more of your GPUs. But just like anything, these cloud providers and these big tech guys, they actually have the firepower in order to do the research, to make the chips happen, and to hire the people that can actually do it. Because this is not something that's cheap. The other good thing, and also bad thing, I guess, at the same time, is this creates a situation where you can actually develop a really big moat around it. So outside of maybe the 3 or 4 major cloud providers, you're not really going to be able to finance all the development around this for the future, So what does that mean for the other, any new entrants? It means that other people are not going to be able to do the same thing. So right now, these guys own the infrastructure, they own the technology, they own the customer relationships. I just don't see a world where Google, in my opinion, within the next probably year and a half, 2 years, is above $200. Because once people figure out how much money Google AI Cloud is going to make, it's going to be just, and it's the same thing with the other companies. What I think is going to happen is over time, NVIDIA is going to eventually get under margin pressure and compression, and the cloud providers will slowly transition away from NVIDIA stuff to their own local stuff. Because right now, NVIDIA is in the lead. I'm not contesting that at all. I'm not. Okay. So right now, NVIDIA can have a pick of the litter when it comes to who they provide GPUs to and at what price. Pricing pressure is one of those things that, what are you going to do with that pricing pressure? Is NVIDIA going to take that money and reinvest it into more R&D so that they stay ahead of these other guys? Do they take that? Do they do an acqui-hire, or do they hire new Yeah, exactly. NVIDIA's, I think Charles Stewart put it there. NVIDIA is going to have to start competing with their current customers. Sick headwind. Yeah, it's a fucking terrible headwind to think about it. But you know, this is all going to the moat for NVIDIA now is probably their developing platform called CUDA. And that's true. You never know where NVIDIA is going to be able to. Maybe NVIDIA is going to partner up with somebody and do their own cloud service where they provide these services and lock everyone else out, and they do it at a price point that's just really attractive. I don't know. Like, these are like business decisions that are way above my head. But in terms of where I think the future is headed, I think that's investing in one of the cloud providers that has a toehold in this technology, like Google, is the way to go.
And I guess my thought process is specifically diving deeper on that Google piece. I mean, we talked about Moore's Law and how often you're going to. So my thought process is how much margin expansion are you going to be able to get, right? The Googles of the world are just getting to a point where they're at a $20-odd billion run rate or something like that in terms of revenue from their cloud, and they're just kind of hit profitability. And I think within the next year or two, they're going to be running at about $2 billion net income. For fiscal year 24, they're probably going to be running at $4 to $5 billion net income for their cloud provider system. My thought process is like, if they're able to nail down these TPUs, is it going to get to a place where it gets even more margin, where your margins are going to start creeping up from not just the 30% range to the 40, the 50%? Because now you're not having to rely on an NVIDIA. You're able to get it at cost and build it yourself. And that's where that $20-odd billion a year of R&D is kind of going into. And I'm just trying to understand, what then these companies already have so much goddamn money. Like, so once they start getting to this place where they're creating their own TPUs to kind of feed their own data centers, it's like now they're going to even have more money because their net margins are going to go up even more. It's like, what's the next thing that they invest in? And it kind of gets me curious. I mean, are the buybacks in Google going to be that significant? Like, like, I'm just like trying to understand. It's like they already have hundreds of billions of dollars. Like, I just, and I guess
they're
my
going
other
to
thought
make,
process is
they're going to make even more. Yeah,
exactly.
Sorry,
It's like, it's not even going to get it. It's not going to get worse. It's only going to get better. My thought process is like, you've mentioned the Google piece a little bit, so I've kind of had that in the back of my mind. Is Microsoft also going down the same path? And I know Apple is very much focused on the M1, but are they? I don't think that they're necessarily focusing as much on the AI path, or maybe at least it's just my thought process, because Siri hasn't changed since 2008. Like, and it has gotten better. I'm just being facetious when I say that, but you know what I mean? Like, I feel like Google's always been at the forefront of AI, regardless of what people think. And Apple always seems to have been trailing. So are they also in that same path where they're creating their chips, or are they lagging behind Google to a very large extent? And then also, Intel barely can make a GPU. Are they just going to continue to fall behind in this world where we're now rapidly going towards AI, because they've barely even touched the surface with kind of creating a very commercialized GPU, and they're just trying to get their footing alone into kind of gaining more revenue, because they've kind of been on an anemic growth path for the past few years. Anyway,
to be fair, I don't 100% know what exactly the long-term trajectory for Google is, but I can tell you what the short term is: make more money. That's pretty much what the general tone for Google is right now. Cut out expenses that you don't need, make more money. Right now, Microsoft came out and is making Google dance, and Google's like, okay, you want us to dance? We're gonna dance. We're gonna dance so fucking hard, you're gonna regret that you called us out. Now, Microsoft's not sitting back and laying down, and Google's not doing the same. Like, Google's bringing back some of their older executives. There's doing Google is in what's the word, like Google search has always been their cash cow, and this finally started to make them a little bit scared. And so Google for the last few years have been kind of like, we're just chilling, like, we're cool. That's not the case at Google. They're in a war. They're literally in like a wartime setting now, which is we are going to make a fuck ton of money and we're going to shut every one of our doubters up. I would not want to be in the path of that kind of logic with these guys. These guys are some of the smartest people on the planet, dude. Just saying. Right now is yeah, it's funny. Does Matt look like Wolverine? Yeah, he does. I actually thought that a couple of times throughout the thing. I was like,
I wake up and I haven't been combing my hair the past couple of days. I've just been like grabbing it and pulling it out at work, and I think this is the end result. So the thing that I have a very quick question. Maybe you know the answer, maybe you don't. I know the whole thing with Ruth has been going on with the other bets at Google.
Yeah.
Sunder's been there a couple years now, right? So like what
he's
caused
been there for
him
a while.
Well, I mean, he's been in the company forever, right? I mean, I think he
Yeah.
graduated into the company, but in terms of being CEO and at the head of the table, I mean, what caused the executive team at Google to stop leaning back in their chairs and put their elbows back on the table and say, let's get after this, right? I mean, I'm just trying to understand. It seems like it was, maybe it's always been that way. It's just now
when you're king of the hill, things can get a little lax, and also I think some of their hiring policies and stuff like that were more geared towards a lot of like political advocacy sometimes, rather than actual like, hey, is this core thing going to help us develop our next leg of innovation? And they've still done well on all of their stuff. So by no means is Google like a slacker, but there was definitely a point where I think Google had to have this come to Jesus moment, especially with Microsoft calling them out on AI, that I think is really like set a different tone at the company right now. Because I think company culture had become kind of bloated a little bit. They had done a shit ton of hiring of people that maybe they didn't even really need. There was a lot of political activism within their own organization where things were becoming a lot more sclerotic. That's what happens, right? When you get fat, dumb, and lazy, one of the consequences that you have is that next time you have to run a marathon, you're not going to do very well. So right now they're in the process, and this is not just Google by any means. This is a lot of other tech companies. They were in this zone of just sclerosis post-COVID that I think that really, like last year, because all of them lost like 30-40% market cap, which is not something that any board is going to take lightly. Right. So I think a lot of, as Meta especially, Meta was down 70% from its highs. Just think about that. So I think a lot of them had really come up with this thing that they needed to do and just become more operating efficient. I think
you realize that though, like these companies are so much younger. A lot of them are, less than 20, 30 years old. And they still kind of recognize it's like, well, how did we get here? We innovated, right? How did we continue to expand? We innovated. Versus like some of these older companies, like I don't want to say the J&Js of the world, but like the Philip Morrises of the world, where it's like all they're making is cigarettes. It's like all you can do is try to make it slightly more efficient, right? Like unless you reinvent the business, you're kind of stuck. And so it's the same thing I see with a lot of oil companies, right? It's like, and you either have one or two things. You either move into renewables or you get more market share of the oil business. Otherwise, you're just going to kind of stay flat, right? And that's why I think so many companies do buybacks and stuff like it. But these guys with their net margins, they're so high already. All they have to do is invest $20 billion in R&D in a year, and they're probably going to make hundreds of billions of dollars from that $20 billion investment.
But Matt, the thing is, it's not so much just investing the capital, but it's also making sure that you're monetizing it at some point. So you're not just throwing in money into just side projects that have no future profitability like baked into them, right? That's the problem that a lot of them ran into, because they were doing so well financially. They thought, well, we can take a gamble on all sorts of like shit that may or may not, like Google was at one point saying, oh, maybe we'll do hot air balloons to provide internet service. Oh, maybe we'll do like, it's literally when you become so big, you start making a lot of bad judgments and bad calls. And it happened at Amazon too. Amazon, they spent $1 billion on Lord of the Rings, like that 8-episode remake. Do you really think that they got a tangible benefit out of spending $1 billion on an 8-episode, which wasn't even good, by the way? This shit sucked, in my opinion.
I still haven't watched it, so don't ruin it.
Yeah.
But but you say, all right. Yeah. How do you know it's not going to turn into a huge cash cow? Like, everyone probably thought Bezos was a dumbass for starting Amazon and selling books online. There's Barnes and Nobles down the street. I'll just go to that, right? So you don't know unless you try it and you fail, right? But I guess maybe you're saying fail quickly. But some of these things take time.
Well, I would say it's good to try new things to a degree that it's not impacting your overall business. That's the problem. When you have it impacting your business and you're not getting the tangible results out of it, you should be willing to make those changes to cut the thing out. Like, have you ever seen Silicon Valley by any chance? The TV show?
Yep.
You remember that episode where they hired Big Head to and put him in charge of R&D? Remember that?
Maybe if you explain it a little bit more, but I've watched pretty much all of them. So
okay, let me show you real quick.
I'm gonna turn off one of these CloudBot settings, the all caps one, because apparently everyone likes to type caps. So let me see, caps protection. Turn it off.
Oh, can you? Okay, here we go. So basically, Gavin Belson's looking for like the next big thing in order to re-energize growth. So he hires Big Head because everyone's like, "Oh my God, Big Head is like the next like super genius guy." And so here we go.
So here goes. By wearing this standard Hooli earbud headphone, modified with a small piezoelectric sensor, the user can control their Hooli phone solely with their neural impulses. Point, click, drag, even type, all using only brainwaves. Think it, and it happens.
Holy shit. Seriously?
Seriously.
This is great. Fuck yes, team. So what's our timeline here? I mean, when can we start testing this? How long before we can integrate this into Nucleus?
Not long. It'll probably happen in our lifetime. We just have to figure out how to make it work. But I really believe that our grandchildren are going to grow up taking this technology for granted.
Our grandchildren?
I know you're single, but you might meet some.
No. What do you have that's ready now?
Well, truth be told, we kind of put all our eggs into this basket, but we do have the kick-ass potato cannon, though. Although actually this one is broken. We tried to put a Mr. Potato Head in it, and it did not like that.
That show, man, is underrated. I'm sad it didn't go for more seasons. One of my favorites is I forget what's the Asian guy's name who just like is
Jin Yang. Question:
Jin,
who is Streamlabs? Is that a bot?
It's a bot, yeah.
It's a bot that's telling the viewers not to really
to write all caps. Yeah, sorry.
I didn't know that. I didn't know that it was a bot. You could actually put a bot that actually.
Yeah, no, I did some crazy stuff. So like I did some stuff in the background. Sorry, I don't want to derail, but like if people give super chats, depending on what ones, it'll either like announce it, they can like have their speech kind of like read out loud. So I forget what the trigger is, but I think if it's like more than like $9 or $10, it'll be like Chris is an idiot. It'll say it on the screen. And,
I thought it was a person. I was like, man, I thought
this guy needs to calm down.
I was like, hey, Streamlab, shut up. Don't tell my boy ET FaceTime he can't caps lock no, or yes,
I think I shut it off. So hopefully it's not yelling like it would have yelled at admit. So I think it's off now. So
it's funny. ET FaceTime like this bot is a fascist.
Yeah.
Sorry, interrupted, man. What were you saying?
No.
Jin Yang.
No, yeah, the seafood app.
Yeah.
It's like it's food, not food, right? I forget what it is. All those crazy apps where you're just like,
no, and it's funny. It's like this is the recipe for 8 ways to make octopus. You know. Oh man, that's too funny. All right, I was about to tell Streamlabs to chill. I'm telling you, dude. I've been watching Streamlabs like the thing for like the last couple of days. Like, man, did Matt hire a fucking mod? Like, you know,
no. Do not yell.
This guy is like taking a really strong stance against people, man. All right, well, it's a bot. Whatever. Go ham on people. Fuck the bot, bro. Fuck the AI. You know.
I think I have to double check it. I think I just put it on easy mode and it ended up being too sensitive. So I'll have to go back and double check.
There you go. There's AI, man. AI is already
man
with our viewers. You know,
right? Jesus.
ET's like, I will not be silenced. AI censor bot. I mean, we're joking about it right now, but dude, imagine like social media platforms put this shit like up, and like anything that you say, if you don't agree with it, it'll automatically not post it. Or like,
well, that's what Elon said about Twitter, right? Like how there's like 3,000 different verbiages or something like that they finally found on the code that were just like blacklisted. And it's like these aren't even bad words. Like it anyway.
It's funny. All right, man. It was a pleasure talking about this. Congrats on NVIDIA on their success. They are absolutely killing it in the market right now. You know, I am not investing in NVIDIA. I'm a Google guy. I'm going to probably put more of my eggs in Google because I see them having a much longer tailwind of profitability, and they have massive share buybacks, and I think they're super undervalued relative to where some of these other guys are. So, you know,
before we sign off, do you think Amazon is also going to be looking at these for their cloud?
Yeah, they're already doing it. They're doing it already, man. They're doing. I could put it up in that video real quick. Let me just put it up 1 second because I think that one was actually really good. Sorry. Share. Okay. Microsoft, Amazon. Okay. Here we go. All right.
Before we talk about Microsoft's AI hardware ambitions, let's take a look at another player that has been under the radar when it comes to custom AI hardware, Amazon. In 2015, Amazon acquired Israel-based Annapurna Labs, a company specialized in AI hardware. Since then, AWS started to offer custom AI chip instances as part of the AWS cloud services, one for inference called Inferentia and one for training called Trainium, with up to 190 teraflops of FP16 performance and 32 GB of HBM memory. Amazon isn't seen as a big player when it comes to AI, but with AWS, they offer a lot of AI compute performance, and part of it is based on Amazon's own custom AI hardware. With the increasing interest in AI workloads, I'm sure Amazon will focus on also increasing their custom AI offerings, not only for AWS clients, but also within the company. And with the deep pockets of Amazon, you should expect more to come. Microsoft is an interesting topic, because on one side they are the main AI player due to the close cooperation with OpenAI. Microsoft operates huge AI clusters with tens of thousands of NVIDIA GPUs. But on the other side, Microsoft is late when it comes to custom silicon. But this is about to change. Codenamed Project Athena, Microsoft is developing its own custom AI chip. We don't have much information at the moment. Supposedly, the design process started in 2019 and the chip has been taped out with first samples available for testing. If all goes well, mass production could start later this year. Now, it's unlikely that Microsoft's first-gen hardware will be immediately able to compete with solutions from NVIDIA, AMD or even Google. But again, the direction is clear. The number one priority is to decrease the cost of inference that ChatGPT and the integration of similar models into Bing Search and Windows and Office products create. I wouldn't be surprised if Athena is targeting inference first, even if it takes another 2 generations. Microsoft's vision of its AI future is certainly not based on NVIDIA GPUs, both for internal use and their Azure customers. Once we know more about Athena, you can expect a video on the hardware details. Last but certainly not least, let's talk about Tesla. Tesla is using neural networks to train their self-driving software, which means they need huge amounts of training power to create a neural network, and then they need efficient inference so that every Tesla car can actually use the AI model while driving. In August of 2021, almost 2 years ago, Tesla announced their custom Dojo D1 chip, although they are only going online this year. The Dojo D1 is produced in TSMC's 7nm node and has a die size of 645 square millimeters. With 354 cores at 2 GHz clock speed, it achieves over 360 FP16 or bfloat 16 teraflops at around 400 watts CDP. But that's not all. Dojo is designed with scalability in mind, connecting them to so-called training tiles with 25 chips each, and then combining 120 of these tiles into a single AI supercomputer with over 1.1 exaflops of bfloat 16 performance. There's so much to say about Dojo, it could fill an entire video of its own, but it reaffirms the same story we have talked about this entire video. Custom AI hardware isn't only the future, it's already here. With the huge AI compute needs Tesla has, custom AI hardware is the only feasible solution. And you can be sure that the next generation of Tesla chips are already being worked on. Circling back to the start of this video, it's interesting that Nvidia is the only truly visible AI hardware company when so much is going on behind the scenes. Literally every big tech company already has custom AI hardware or is working hard to get there. And while the first generation hardware might not be able to compete Nvidia in terms of performance, efficiency or scalability, I'm pretty confident that in 5 years' time, all big players will rely on their custom AI chips. But not only big tech is changing. If you can't afford to design your own custom AI chip, companies like TensorRT are hard at work to outcompete Nvidia with chips only made for machine learning. At the same time, a lot of compute is starting to move from the cloud to the edge. This Coral AI Edge TPU is based on Google technology and provides about 4 TOPS of Int 8 at only 2 watts. Your mobile phone most likely has an integrated AI chip, like Apple's neural processing unit. At this week's WWDC, Apple announced that autocorrect is moving to a machine learning model, directly running on the NBU inside your iPhone. AMD's latest Ryzen 7000 Phoenix mobile CPUs and Intel's next-gen Meteor Lake also include custom AI hardware. The revolution has already started. Now the only question is, who will come out on top? You know what to do if you enjoyed this video, and see you in the next.
Yeah. So this is right now, Nvidia's got no competition. In the future, they might have some competition. So just competition has a way of competing away profits. So yep.
I do have a question, and then I know let's get out of here because I know you've been trying to edit it as well. So do you think that Wall Street is putting into the valuations some of this? So meaning like Microsoft is trading at a 30 odd PE, maybe even higher. Do you think that that is taking into account some of this efficiencies that they'll be able to see in terms of net margin and things of the like? Obviously, revenue is going to continue to grow at a pretty rapid pace, but say they're able to shave another 5% off of their cost of goods or their overhead, you know, that's going to have a huge bottom line impact to their net income. So that would technically increase, let's just say, net income in fiscal year 25 or 26 when these things truly start to have that impact.
Well, remember, this is a business expansion opportunity for all the cloud providers, because essentially, if AI is the future, which it clearly is, because we're seeing so many use cases populate, right? The thing that we want to see is, okay, in terms of these companies, how are they going to materially increase revenues, right? Because eventually you're going to hit a point, like a saturation point, where you've grown so much. So you need new technology to come in and basically do the heavy lifting, right? So let's take a look at just quickly on Microsoft historically. So right here, as everyone can see, this is Microsoft's income over time. You can see here, nice steady revenue growth every year, just keeps growing on a net income basis is growing. They use share buybacks, so that means that the shares become more valuable. Like literally, this is the perfect stock essentially. Every year, they generate more money. They take the profit, they buy back shares, they return it to dividends. And you can see here, look at this. They've constantly been increasing their their revenues up. Their operating income, you can see here, every year grows, and it keeps compounding on itself. And then on top of it, they use that money to buy back shares. So that is, where's the damn shares outstanding? Okay, balance sheet. Actually, cash flow statement is probably where you're going to see that. So in terms of cash flow, you can see here on a this is the free cash flow, but we're looking at right here, net issuance of common stock. So every year they're just buying back more and more shares. And so the pie just keeps shrinking. Look at how much money every quarter. First they spent 13 billion, then 15, 17, 14, and it just goes on and on and on. So as they make more money, they do more share buybacks, which means the share count goes down, share price goes up, and everyone is happy. And then at the same time, they're also paying dividends, right? So you're seeing this tremendous amount of cash that these businesses are generating. But then there comes a point where you see this growth, how it eventually will subside somehow, because maybe like they've hit a saturation point with some of this stuff. I think AI is going to be the next leg that gives them another 10 years of this right here. You see this? Another 10 years of this is going to happen for these big guys, where every year they're going to grow by about 10% CAGR. And which means it'll keep compounding themselves. And then when you combine that with the share buybacks, it means a huge share increase in price, which means it benefits us as shareholders, right? And that's why I wanted to just quickly show you guys what it looks like on Google's end. Because Google now is getting back into the same zone of getting back into that operating cash flow right here. Let me just see. This is revenue. Let's look at the operating cash flow. Their operating cash flow, they had such a big bump post-COVID. Literally, they went from operating cash from 34 billion to 78 to almost 82 billion dollars, okay, on a TTM basis. This is where they got fat, dumb, and lazy, pretty much, because they were just chilling on their butts. And then they started investing in so many things, the operating income started to go down. Now they're becoming more efficient. Operating income is literally on its trajectory this way, like straight up this way. And you can see the gradual improvements over the last year. So they went from operating income from -5% year over year to 0 to 3. And eventually I think they're going to get to something like this, 18, 20, 26% back to being.
Do you think that just wasn't the normalization of the pandemic kind of just coming through? I mean, think about how much time people are spending at home, how much YouTube, all that. I mean,
No, because their revenue is still climbing, because their revenue wasn't the one that was the problem. If you look at Google's revenue, right?
Okay.
It didn't take a revenue drop. You see that?
Yeah, I see what you're saying.
The problem is they were overspending.
Their margins were going down. Yeah.
Yeah, they were overspending on stuff, and it was things that weren't tangibly getting them benefits. So this is the case for Google going forward. And like I said, now with the buybacks getting factored into their calculations, if you look at their cash flow statement, they authorized, I think, 70 billion in buybacks. They don't even have a fucking dividend, man. So all of their money is going straight into buybacks. Right here. So net issuance of common. Look at how much money on a TTM basis they're going to be spending on buybacks. Right now it's 60. They're actually ramping that up to 70 billion on share buybacks. So
crazy.
Yeah, man. It's
Absolutely
nuts. It is nuts. Absolutely. So think about it, how much on a per day basis these guys are going to be doing share buybacks. It's nuts. I'm telling you, Google is at this point, Google is such a no-brainer, man. Like,
I mean, from even a valuation perspective, even if their income stayed flat, I mean, they're just undervalued compared to the rest. But hey,
Yeah.
I want everyone to take a quick look. I mean, Chris does a really good job here on CashFlow Chronicles, but he is also putting out really good opportunities for further stuff and due diligence on a very high level basis on Patreon. And I think that you guys, even if it's what is it, $5 and $10 a month, Chris, for kind of the first 2 years, and the amount of value that you get for that is crazy. He talks about end phase. I mean, you're writing at least an article a day.
I try to. Yeah.
It's absurd.
Yeah, and the thing is, like, I try to do a lot of granular research, which not a lot of people want to cover, because it's very surface level. If anytime you watch stuff on CNBC or anything, they only like speak about like the general market trends, whereas I try to dig deep. Like, you've seen the research that I do; it actually looks into a lot of factors, and when it comes to due diligence, it goes into like individual level changes that are being made, so that this way you can see the light at the end of the tunnel and why this is a good investment or a bad one, as opposed to just saying, hey, this is a good investment because they because of this. Like, no, like you want to actually see that gradual change happening at the company level that can really generate a lot of alpha. The one thing I don't do is I don't give the first 2 tiers a structured way on where my price targeting is, because that I think like you need a little bit more like advanced understanding of why the logic is the way it is and what the timing is. So a lot of people, like Chris is a trader. Like, yeah, I am a trader to a degree because I see sometimes things and I want to make sure that I capitalize on it. But there are strategies and time sensitive strategies that if you applied them right, you could do a 5x in a year. It's not hard.
Yeah.
It's just knowing what you have on your hands. So
Yeah. Cool.
Yeah.
Well, you guys, be careful of the exclamation points. So Streamlabs is talking. Much appreciated as always, Chris. I learned a lot today, and it definitely makes me think about how little I know about this upcoming world. And I think about this as well because, like, I'm not the best coder, and people run circles around me around code.
If you have 1 minute, I want to show you something that actually meta. I actually kind of know, like, based on carnal knowledge of something that's happening in the background. Well, I don't have like that much input into it, but I actually know a few people who worked on this project, and it's really cool because I got to see it live. Let's share my screen.
Another 43 of you guys, please make sure you guys are subscribed as well. We try to do this, at least 3-4 times a week. So,
yep.
Oh, you did show me this like not too long
When a
ago.
patient is scanned for an MRI, high-powered magnets and radio waves gather raw data to create images of their anatomy. But capturing all this data can take up to an hour, which can be difficult or impossible for some patients who can't stay still like small children. Long scan times also limit how many patients can be evaluated in a day, especially in places with limited MRI access. It also means that MRIs could be too slow for emergency situations like strokes, where doctors need images quickly.
With Fast MRI, NYU Langone and Facebook AI are using artificial intelligence to make MRI scans much faster. To do this, we created the largest open-source de-identified MRI dataset and used it to train a deep neural network. This enables our AI to generate accurate images from far less data. Since less data is needed, scans can be much faster.
We've now completed the first major test for Fast MRI. In a rigorous clinical study, radiologists found AI-generated images created with 4 times less data were diagnostically interchangeable with traditional MRIs. Additional testing is currently underway, but the study shows that with AI, we can significantly improve the patient experience and provide the benefits of MRIs to many more people. And we believe this open collaboration between AI researchers and medical...
So why I think this is important, and I'm glad Charles Stewart, maybe he's in the medical field. One of the things that when you do a CAT scan, right now the gold standard for diagnosing a stroke is CT. So you put them in CT, it takes literally boom, 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 2 seconds scan, you're done. The machine, already sends it out, and you're able to determine whether the person's has an active bleed or not. Game changer when it first came out. The problem is the problem that you have with it is that if you have an old stroke, like a previous stroke, and you try to layer it with CT, it's hard to differentiate. But the way that MRI works is that you're using a different scanning technique, right? And because of that, you're actually able to literally it's like a Christmas tree when you actually have a stroke on an MRI. The problem with an MRI is that it takes a while to get the patient in, and even if you're trying to do the scan, like the scan that I'm talking about, something called a diffusion, like a diffusion scan, you're able to see it right away. Now, the thing is, if you're able to really speed up the MRI process, you could literally save lives. This is one of the things that's happening. And also, MRI, one of the problems is sometimes it can take a really long time to scan a body part, and the patients have to stay in a very fixed position for a prolonged period of time. If they move even slightly, it degrades the image and can really and it's also some claustrophobia involved with it. So the entire MRI experience is actually, even after all the great things we try to do, is still a very rough thing to go through. But with AI now, you're actually able to reduce down the scan time significantly. Problem with all medical imaging is that time was detail. Yeah. And so AI is helping kind of reduce the time it takes to do what needs to be done. I work with a software tool that actually helps using machine learning and AI algorithms. So what happens is a CT is done on a patient with a stroke. The machine learning algorithm detects whether the patient has a stroke or not and automatically alerts the operating room, like via text message, the chief of neurosurgery, whoever's on call, text message everything. And basically that person, now time off the table, is already on their way to the OR. The OR team's already prepped, ready to go. And all the radiologist has to do at that point is just confirm whether the patient actually has a stroke or not. And it's actually really accurate. So the key to stroke is the faster you react, the better the outcome is for the patient. So right now, the time it takes to diagnose a stroke and intervene is going down so significantly that it's amazing to see. And it's all because of the magic of AI. And people, like I said, these are not things that you guys are gonna see like up front, but I'm sure that one day you will go to a hospital, and if you have a stroke, you're gonna thank God that the AI was there to detect all sorts of anomalies, all sorts of things, and basically assist the radiologists, assist the surgeons, assist the doctors in helping reduce down the effective time it took to take care of you. In which case you'll have a much, much better outcome. Yeah.
That's why they pay the big bucks, man. That's why they got you working overnight.
I know.
Yeah.
Trust me, if you guys only knew half the shit that I'm actually involved with, you'd be like, Chris, what the fuck are you doing on YouTube, man? You should be somewhere else figuring better things out with your time, so it's same thing with you, Matt. You're in the same position. I'm sure that you do way more important things than this YouTube thing, right?
Nah, I mean, I just try to provide the world with energy, man. I mean, that's all I do. I mean, I try to put holes in the ground and hopefully find oil, and that's kind of the goal. And I love investing. I'm able to do it in my day-to-day job as well. It's like, people might think it's like, oh, but you have to make PowerPoint. I'm a PowerPoint engineer, God, whatever the hell. But at the end of the day, I'm just trying to make investments so that people can light their homes, get from point A to point B, and really be able to power their lives and in a manner which they don't have to fight for, right? 100 million barrels of oil a day are used, and I feel like most people don't even realize it.
Yeah, Matt and me are the unsung heroes that make your life easy to live, basically. Outside of our YouTube, speculation and Wall Street bets and gambling, we're actually really key members to making sure modern society works.
Nah, I just love oil. It's a good time. But
as
always, man,
I love healthcare.
I appreciate it, and as always, you educated me tonight, and I need to do more research as always when having a conversation with you. So I'll talk to you.
Yep. Always a pleasure, man.
No, we have tomorrow as well. Okay. For some reason, I thought today was Thursday. So I will see you tomorrow, my friend.
I'm getting lost on the timing too, man. But yeah, I'll see you.
Cool, man. Have a good night.
Later, dude. Take care.
Cheers, man.